Hello everyone. We will continue our topic. In the second part, we will talk about acids, bases, and salts. You see acids and bases everywhere in your life. What are we going to learn in this topic? We will define acid and base. We will talk about Arrhenius theory. That is a scientific definition of acids and bases. We will talk about strong and weak acids and bases. We will talk neutralization reactions and how to make salt. We will talk titration techniques, pH values, indicators, and some examples of acids and bases in our life. Where do we use them and why they are important to know. So, from vinegar in your kitchen cabinet to the soap in your shower, acids and bases are everywhere. And what does it mean to say that something in acid is acidic or basic? And in order to answer this question, we need to examine some theories describing acids and bases. And we will focus on Arrhenius theory in this topic. So I put some examples for the acids and base. The citrus, fruits, tea, coffee, vinegar, even milk is acidic because of the protein, amino acids in it. Soda, apples, they have fruit acids. What are the common bases? Baking soda, lye, soap, ammonia to clean for cleaning purposes. You can think all cleaning products are basic. Antacids for your stomach, they are all bases that we have in our house. So let's talk about Arrhenius theory. This is Svante Arrhenius. He is a famous physicist and chemist actually. So he developed physical chemistry. And he is the third Nobel winner in chemistry because of his work in acids and bases. So he described behavior of acids and bases. Okay, and he suggests classifying certain compounds as acids and bases on what kind of ions formed when the compound was added to water. When you mix a compound with water, what type of behavior it makes, then you can tell if it is acidic or basic. Now, what is an acid? We say if the pH is less than 7, it is acidic. We will go and talk about pH in another video. If it neutralizes base, it is acid. We can also say that. Or when it forms hydrogen positive ions in solution, it is acidic. Or we can say corrosive reacts with most metals to form hydrogen gas. So acids are reacting with metals and they form hydrogen gas. And they are good conductors of electricity. That is why we have acids and bases in our batteries. So they conduct electricity. If we want to define acid, so these are all properties and definitions of acids, but if we want to use our Arrhenius theory, how are we gonna define it? Arrhenius said, acids yield hydrogen ion as the only positive ion in aqueous solution. This AQ means hydrogen ion in water, which is aqueous solution. The hydrogen ion may also be written as hydronium. Let me fix this one. That's going to be a format text sub, and that's going to be a and format text super. Yes, this is hydronium ion, which is a positive hydrogen ion combined with water. Okay, so that is a nitric acid. nitric acid. Nitric acids are in apple vinegar, for example. If you have apple vinegar, it has nitric acid in it. So nitric acid, if you mix this nitric acid with water, it is going to form, why don't we have this? Let's add insert special character. We want this arrow. Okay, fix it. Nitric acid mixed with water, it is going to form hydronium ion and nitrite ion. Okay, ion. They form ions. Remember ions, positive or negative, cation or anion. So if you mix acid with water, it is going to form hydronium ion, that is called Arrhenius acid. Okay, if in the regions they ask this way, which one is a Arrhenius acid? So you are going to check for this hydrogen. If it has this hydrogen, it is going to combine with water and it is going to form hydronium ion. Then we are going to say, okay, that is a Arrhenius acid. Guys, Arrhenius acids and regular acids are just same thing, but in a scientific way. Like Arrhenius help us to define the compounds in a scientific way. Okay, so there is nothing special about Arrhenius acid or Arrhenius base. Acid is acid, base is base. But in chemistry, we follow the definition that the Arrhenius define. Okay, so we are just following the path. So we will put them in an order. If a compound mixed with water and it gives off hydronium ion, we call it Arrhenius acid. That's all. You can also call it acid, but this definition is coming from Arrhenius. Svante Arrhenius. So we also have weak and strong acid. Weak acids do not ionize properly, which means you mix them with water, but they do not make the water very acidic. So the pH is changing very little. For example, pH of water is 7, neutral. If you add weak acid, it's just maybe gonna be like 6.8 because they will not give the hydrogen ion very easily. If it is strong acid, they ionize completely. Like hydrochloric acid, nitric acid, sulfuric acid, hydroionic acid, they are very strong acid because they give this hydrogen to the water and they form lots of hydronium ion. Here I want to stop and I want to let me first show you some common acids, and then I want to show you a video about acids. So this is hydrochloric acid, that's in your stomach. That is very strong acid. Sulfuric acid, nitric acid, acetic acid in vinegar, carbonic acid in sodas, phosphoric acid, that is the flavoring acid. So these are all common acids here. Now I want to show you a video about certain acids. When I was working in the lab, there was a hydrofluoric acid, HF, and they say be very careful with this acid. That is the strongest acid. If you accidentally touch this acid, it's gonna penetrate through your skin and it will start to eat your bones. That was what we were told. I want to show you a video about hydrofluoric acid next.
By what they've always been told, that HF, hydrofluoric acid, eats human flesh. We thought that we should try it. Now, obviously, we can't try human flesh, and Brady decided that a chicken's leg, that's an uncooked leg from a dead chicken, is a reasonable approximation to a finger. We decided that we should try and do a demonstration, but with some controls so we could compare them. And what we wanted to know was what was special about HF. Was it the acid or was it the fluorine? So we thought if we took two other acids, HCl, hydrogen chloride, and sulfuric acid, both of those have the H, the acid part, but they don't have the fluorine. I had been told that HF attacked your nerves so quickly that if you stuck your finger in it, and none of us obviously would try this, that it destroyed the nerves really quickly, so you could hardly feel anything. There are stories of people whose gloves have leaked and they've taken out their hands and bits are missing. And of course, HF features in the TV show Breaking Bad, which I'm glad to say I've never seen.
Why are you glad to say that? It's really good.
Well, perhaps one day I might watch it when I'm old. After 5 minutes, nothing.
Okay, this is 5 minute mark.
After half an hour, nothing.
This is half an hour.
At the end of the day, something slightly might have happened. We decided to call it a day, but just in case, to leave it overnight in the acid. In the morning, it was really interesting. The 2 chicken legs in the control acid, HCl sulfuric acid, had made quite strong colour in the liquid. And the bits of the chicken legs sticking out still look quite healthy. You could almost imagine cooking them. But the leg in the HF was pale, looked decidedly dead. So we lifted them out. The ones in HCl and sulfuric acid had turned rather jelly-like.
Good. You're right, she's done.
And really looked almost like an advertisement for being a vegetarian. Really yucky. But with the HF, it was quite different. It was as if a surgeon had chopped the bottom off. It was moderately interesting what had happened below the surface, but really what was much more interesting to me is why the chicken leg in HF looked as if it was dead. And clearly what had happened is that some of the pigment, some of the red colour of the meat had been bleached away. The reason that meat is red.
I'm going to stop here. You can go ahead and watch the rest. But these are some acids, very strong acids and very acids. Please pay attention what common they have. They have hydrogen in their contents, okay? So hydrogen chloride, hydrogen fluoride, sulfuric acid, and it has 2 hydrogen. And in the rest of the video, he explains why the hydrogen fluoride looks very dead, like no red, bloody tissues there. And he will explain it in the rest of the video. I recommend you to watch it if you are curious about the rest of the topic. I'm gonna stop here, guys. Then we will continue bases in the next video. Bye.
Is because